Hello everyone, welcome to the fourth video in this series. In this video, I will guide you through the results of the analysis. Specifically, this video will cover the contents of the results folder and guide you through interpreting the tabular results and geospatial outputs. So let's get started. So the first thing we'll have to do is navigate to the output folder where we had the tool save our output results. So in this case, it was for me at least, it was the empty folder called output in the source directory. And so if I open that up, we'll see that a folder has been created called results, followed by a series of numbers. So the series of numbers is a timestamp, with the first two digits here being the year, followed by the month and the day. So this analysis was conducted in 2022, September 13th, and this is the time, so approximately 2:21 p.m. So if we expand this, we'll see the contents of results folder here. So we have the CSI GDB, so this contains the spatial data, contains a feature class with the calculated results of the analysis, which is later displayed in the ArcMap document, which we'll be covering towards the end of this video. We then have the stat folder, and so if we expand this, we see we have an Excel spreadsheet here called results, and this contains the tabular and statistics data produced from the analysis, which we'll cover in this video shortly. We have stat CSI. In here we have a series of files that can be used for conducting a sensitivity analysis. If you produced multiple scenarios and wanted to do a sensitivity analysis to compare between your scenarios. And then we have our config file. This is what I talked about in the previous videos, and this can be used as a source of documentation for the parameters used in running this particular set of analysis. And this can also be loaded back into the tool if you wanted to redo these analyses or make some slight modifications. And then, like I mentioned previously, this is the ArcMap document, which visually displays the spatial data results. And it's based on the template document we discussed in our previous videos. The symbology of the template document is applied to the output spatial data, and it's displayed in this ArcMap document here, which will be covered towards the end of this video. So let's get started looking at some of the tabular results. So we're going to open the stats folder. And then we're going to open the results workbook. And so when that opens, we can see there's a series of different sheets that separate our results into a series of different categories. We'll start with the first sheet here, global stats. And so this sheet provides a summary of the settings used for calculating the CSI scenario, as well as identifying the scenario name. If we had additional scenarios, they would be listed in the subsequent rows here, along with their settings. And this is a quick way to reference to see what the different settings were between our scenarios, for instance. Then we have the scenario name again, followed by some descriptive statistics, telling us, sort of summarizing some of the outputs of our results. And so the first column here is the count of river reaches, so it's the number of river reaches that were analyzed in this scenario. Next we have the count of river reaches affected, so this was the number of river reaches that were impacted in the analysis. Then we have the percent river reaches affected, so we just express this in a percent form. Then we have mean CSI, the count of non-free flowing, and that is also expressed as a percent. And then we have the bench match, which indicates the number of benchmark rivers that our model also determined to be free flowing. Next we have the global DOM sheet. And so this sheet presents some of the information about the dominant pressure indicators. So here we have the scenario name. If we had additional scenarios, they would be listed here. And then we have the pressure indicators. And for each of these, we have the number of river reaches where this pressure indicator was indicated as the dominant pressure. So in this case, the degree of fragmentation had the greatest number, or impacted the greatest number of river reaches at 5,717, followed by degree of regulation at 576, and the sediment trapping index at 295. Next we have bench DOM, which provides information about the benchmarking process. So here we have the scenario name. If we had additional scenarios, they'd be listed below. And in this instance, all of our benchmark rivers were identified as free flowing. If we had a benchmark river that the model said was not free-flowing, but expert opinion said was, we'd get some additional information about the benchmark river here, such as its name and the certain pressure indicator that was affecting it. Next, we have river stats. So this provides information about rivers rather than river reaches, and it's broken down into different length categories, as well as the free-flowing status. So values of 1 in this column indicate rivers that are free-flowing, and a value of 3 indicates rivers that are not free-flowing. And then we have some descriptive statistics for these length and free-flowing categories, such as the volume of the river in 1,000 cubic meters, the length of rivers in kilometers, as well as the number of rivers and whether and the number of rivers that are connected to the ocean. Next, we have River Stats 2, which is very similar to River Stats 1, except for we have an additional category, free-flowing status 2 in this case, which is refers to rivers with good connectivity status. These rivers are not free-flowing, but they maintain good connectivity status over a large portion of the river. So we thought it important to include them as an additional category here, and this is where we present statistics on those. River Stats Good provides similar statistics to discussed in the previous 2 pages. And then lastly, we have a list of free-flowing rivers. This is a list of rivers that are determined to be free-flowing, but these are rivers that were longer than the minimum length threshold that we specified in our general settings. So if we remember back to when we specified general settings in the tool, we specified a value of 100, which referred to 100 kilometers. So all of these rivers here are rivers that are free-flowing and are greater than 100 kilometers. Whatever number you input in the general settings is appended here, so you can it's easy to recall what your general setting number was for the minimum length threshold. And then we have some information about those free-flowing rivers, such as the basin they belong into, their identifier, their name, the country they belong in, their length in kilometers, their river order, whether they're connected to the ocean, and the basin they're in. So that brings us to the end of the tabular results. Next, we're going to go look at the geospatial results. So we're going to navigate back to our results folder, and then we're going to open the ArcMap document here. Okay, so now that that's open, I'm going to guide us through some of the output map results we have here. I'm just going to close this. I'm going to turn this off for now. We're going to bring in the CSI feature class that's stored in the CSI geodatabase. This is the feature class that has the attributes that we're using to make these map outputs. So I'll just guide you through the attribute table of this bit of data. So we're going to open the attribute table here. And so the attribute table will look very similar to the attribute table of the streams feature class. It's used as the input because that's what the feature class is based off of. And the fields that we'll be using to make these map outputs, or that were used, are we have our individual indicators here, the 6 that were used in calculating our CSI, and so those are displayed in these 6 layers here. And then we also have our CSI, which is sort of our main output, and it's displayed in this layer here. We also have our dominant pressure indicators. These are indicate which of our pressure indicators is the most dominant for these river reaches. And those are covered in the MapDom imp for impacted rivers, and MapDom all, which is for all of our rivers layers. And then we have a series of columns here that are indicate our free-flowing river status, and particularly this one here. Contains values for free-flowing rivers, rivers with good connectivity status, and non-free-flowing rivers. And those attributes are used in our map FFR status document here. So those are the attributes that we're using in the CSI feature class created for our scenario. I'll remove that now. And then we also, in addition to those outputs, we have some of our input variables here as well, such as our barriers. So we just have a quick map showing our included barriers here in orange triangles, and those are scaled based on the storage volume of those barriers. And then we also have our excluded barriers here, shown in gray, using a similar graduated color, or graduated symbol size scheme. We also have our benchmark rivers here, shown in yellow, indicating where those are. Okay, so moving on to map CSI. This might take a moment to draw, so we'll just wait for that. So this layer here indicates the CSI values of our river reaches, and those are shown here with rivers in red having a lower CSI value, whereas rivers in green have a higher connectivity status index, indicating that they're more free-flowing. Next we have our map FFR status. So here we'll just wait for that one to draw as well. So this layer here indicates which rivers have been classified as impacted rivers, and those ones are shown in red and are broken down into categories of very long to short, with our longer rivers having a darker color and our shorter rivers having a lighter color. And so any of the rivers on our map here in red are considered non-free-flowing. Then we have our rivers with good connectivity status, and these are shown in green, with darker green for longer rivers and a lighter green for shorter rivers. And then in blue we have our free-flowing rivers. Again, very long rivers are shown in a darker shade, and shorter rivers are shown in a lighter shade. Moving on to our dominant pressure indicators. So we'll look at our impacted rivers first, and we'll wait for that to draw. Okay, so this layer shows the dominant pressure indicators for our impacted rivers, and it's broken down categorically based on the pressure indicators. So our degree of fragmentation pressure indicator here, our rivers impacted prominently by that indicator, are shown here in red, followed by degree of regulation in orange, and in yellow we have the sediment trapping index. Similarly, our map DOM all is broken down in a similar manner as our impacted, except for instead of just showing the dominant pressure indicators for our impacted rivers, it shows them for all of our rivers. And so here I will draw that one quickly here. We'll wait for that to draw. So now we can see the pressure indicators that are impacting all of our river reaches. I guess I'll also note that each of these maps is composed of different layer groups, and which are based on the river order. So larger rivers are given a thicker line width, and smaller rivers are given a more narrow line width to create this gradation of river size that we see in our maps. Next we have our individual pressure indicators. So here we'll draw a map DOF for degree of fragmentation. So this is the calculated degree of fragmentation results. We can see here that it's broken down with darker or red colors are areas that are impacted by degree of fragmentation, whereas lighter green colors are areas that are not impacted by or have less of an impact of degree of fragmentation. And a similar color scheme is applied for all of our pressure indicators. So here we'll take a look at degree of regulation next. We'll wait for that one to load. So we can see we're using a similar color scheme here. Again, areas in red have a higher degree of regulation impact, whereas lighter green colors do not. They have a lower degree of regulation impact. And so with these 6 layers, we can sort of get a sense of the which pressures are impacting different areas of our map and how those are influencing our CSI values. So that brings us to the end of this video, where we covered the contents of the results folder. I provided a brief description for each of the files created in the results folder, as well as guiding you through interpreting some of the results of the tabular results created in an Excel workbook, and looking over the spatial data results created in this ArcMap document here.